Today I'm going to run two tests. First one is a duct leakage test, and the second one is a total system airflow test. Most people look at this device here and think this is just a leak detector, and it does really well at that. The first test we're going to do is a duct leakage test by hooking it up, sealing everything off, and measuring the airflow. The second test is going to be pressure balancing, using this as a flow hood and testing the system airflow. Now the first one is going to tell you how much is leaking, obviously. The second one is going to confirm how much airflow is actually moving into the conditioned space. To do those tests, we're going to use a Retrotec duct tester fan. So I'm going to get this hooked up, and we're going to do the total airflow test first, and then we're going to test, seal everything off, and do a duct leakage test. All right, a couple reasons why I want to do a total system airflow test. One of them is I want to ensure the right amount of CFM is going in and out of this mixing hallway, so that I can better calculate when this puts out 100 CFM and that puts out 100 CFM, that I still have a negative pressure inside of this room. The other one is I want to ensure that the system is running correctly. So it's a 2-ton system, should be moving 800 CFM at the high setting, and I believe it's around 400 CFM at the low setting. The static pressure testing showed that it was 0.5 inches of water column, so it should be in the right amount of static pressure. So the total system airflow should be accurate. Having a low airflow rate will reduce the amount of noise that's generated from the ductwork, because it's at the lower airflow will have less resistance. So I want to ensure that the system is running around 400 CFM on the low setting. All right, I got the test set up to run a total system airflow test. This probe here is going to measure the static pressure inside of the ductwork. All right, I set the pressure to 0 pascals, and it's reading 460 CFM, so that's pretty good. That's right around 400 CFM that I was searching for, and the fan speed is on low. 2 bars means low, 3 bars means medium, and 4 bars means high. Now I'm going to do a duct leakage test. So I'm going to shut the system off, and then I'm going to go around and cover all of these grates. All right, I got all these covered, mudroom's covered, and this is one of the ones that is in the kitchen that blows out. I got a probe in there, and now that's going to the manometer. So now the fan is switched around, and I'm going to be pulling air out of the system without it running. I'm going to set the pressure to 25 pascals. I had to change the range to 74. So I got the setup going now. The probe is up in the closest vent, and the duct fan is running, I think it's only at like 17% speed. Negative 25 pascals of pressure, and it's around 70 CFM for leakage in the ductwork. You're allowed 4 CFM per 100 square feet. So 26 times 4 is 104. I'm allowed 104 CFM, and I'm at 70. Now New Hampshire's code is 8 CFM per 100 square feet, so I'm allowed 208 CFM, but I'm only at 70. So the system's pretty tight. I'm happy with how it's performed, and I'm happy with the flow rates. Now let's talk about why you want to do a duct leakage test. So they are required anytime the ductwork is outside of the conditioned space, meaning insulated and heated or cooled. The reason why you want to do a duct leakage test is to ensure that the duct is tight and not leaking a bunch of conditioned air into unconditioned space. Obviously, you're going to lose a lot of energy that way. You could also be sucking in a lot of nasty stuff. So if you're in a basement that isn't conditioned, or a crawl space that isn't conditioned, and the cold air returned is inside of that space, you could be sucking a lot of dust, debris, pollen, particulate matter, VOCs, chemicals, all of that stuff into the system, which is obviously going to push it inside of the home. So indoor air quality is part of it. Another reason is energy efficiency. Another reason is equipment longevity. If you have a lot of leakage and the cold air return is sucking a lot of that stuff in, and it sticks to the coils in the air conditioning system, That's going to create a lot more static pressure build up over time. It's going to clog the filters. That static pressure is then going to increase the strain on the blower motor and could burn it out. Another reason why you want to have duct leakage testing is to ensure that it's working properly so that they're not leaking all of that conditioned air into an unconditioned space. So if you're going to pay to heat the air, it might as well go to where it's supposed to. The final reason you want to do this is because it's required by code. It's even required in New Hampshire, where it's currently 8 CFM per 100 square feet. All right, so we ran two tests. We ran a duct leakage test and a total system airflow test. The duct leakage test is going to tell us the integrity of the piping system to ensure that it is going to provide proper airflow. The total system airflow test is confirming that the amount of airflow we're looking for is actually being achieved. All right, if you need blower door testing, duct leakage testing, total air system flow testing, range hood testing, ERV balancing, thermal imaging or data logging or moisture investigations, anything building science related in the state of New Hampshire, you can call, text, or email Sean Baldwin at SBC Testing.